Okay, we're back again into my live stream, and in today's live stream I'd like to learn about motion canvas, and I'm using my mic right now because for the previous live stream I don't use this. Okay, what I've done is using the signal for motion canvas, and we continue our lesson. But I think I need to test my knowledge first to reinforce what I've already learned by recreating this particular thing. So what I've done is just basic animation with circle, and then we have the line, the text, and the text below the circle. And we recreate this thing from scratch. I think first of all we have the fill add, and we need to add the node itself into the fill. So we will have the circle. Let's fill it with red, and then maybe the size is 100. Okay, the size must be the number, and we look what we got. Okay, we got that. So we need to have the scale, maybe scale 100, and we make the size of a scale times 2, maybe times 2 again. But we see what happened here. Scale is 100 or radius. Okay, we need to make it by radius. We have radius 3 because the circle formula is where is the formula? So this one, if we want to calculate the area of our circle, we can use PR to PR square. So I need to make the area itself cons area equal with create signal, and cons radius is create signal. Let's make the radius is 3, and the signal is the callback function, because we can use the callback function in create signal, not just by passing the primitive value like 3. So we can create this as well, like math.p times radius, and if you want to call the if you want to get the radius value, you can type radius with function like this. So it will give us the signal value, then times radius, right? Area equal with p radius square. This one, area is p radius square. We get that so far. What we need to do next, maybe scale times radius. a radius function like that. Yep, we get this, but we need to make it scale by 2 because we want to add the line after this circle later. Let me create this one. We can have line, stroke of black. If we are using line in motion canvas, we should add the points. So we hard code the points first. Maybe maybe like 0 to 200. If we look here, there's nothing because we need to make the line width, I think. Line width. Yeah, we got that. So this is what we got. What we got if we add the points and we make it 0 to 200, it will be like this. Maybe we can hover 0 to 200. 0, this one is 0, you can check it in here, and this one is 200, 200, 200, 200. Okay, that's great, but we can use factor 2 inside it. So factor 2, you can learn about it in motion canvas factor 2 documentation. Or if you want to get more depth, you can clone this repository from motion canvas, and then I've cloned this code base. And let me check out the main repository first, main branch first, and we can search the factor 2. Where's the factor 2 implementation? Core factor 2. Where is that? Maybe we search in factor 2 motion canvas in types, motion canvas core types factor 2, type factor. Okay, this is the class that represent a two-dimensional vector. You see that in here, you can grab different things like vector 2. So if you don't know about the JavaScript, you can call the class itself like this one. Maybe I need to create like this. Maybe I just we can access the class like vector 2.0, so we can grab this 0 or 1, right, left, up, down. Let me see the practical example. So first vector 2.0, and then we need to move the arrow from 0 to the right with some number. So we can use vector 2.right. I think we can call the callback here vector 2, or not the callback. It has no call signature. Right, new vector 2. Okay, what we got? Right. Oh, yep. We need, because this is a function, we should call it inside the function itself. So maybe it's better to make it like this one. Vector 2 dot right. Dot scale. Okay. Why we need to use scale? Okay, we need to use scale here. Let's look. Okay, we get that. But we need to have from 0 to the radius. 0 times radius. From 0, it will be the radius times scale, I think. Radius times scale. Yep, we got that. And we can use start arrow and end arrow. Yep, so far it's great. The next one, we make the text. Text will have the text attribute. This might be r equal with radius. Oh, we should have this, and we can animate the radius itself. Yield radius dot dot signal, maybe. I forget about this one. To fix it 2. Okay. No. Oh, we can change it directly. Back 2 seconds. Okay, the circle itself, should we make it as a function? Oh, this is something interesting. If we just use the value itself inside our size props, it will get the static value. But if we make it as a function like this and we try, yeah, we have the dynamic value. And then what should I do next? Const text style, font size 64, offset y is -1, and we can apply it here. Text style. So far it's great. Okay, we yield the radius and we get the radius. Oh, again, because I just type the value that I want to display inside our text props. But if we want to make it dynamic, don't forget to make it as a function. Look at this. Okay, we get that. And don't forget we have to fix 2. Okay, that's great. Something great. I need to copy the text style because I don't know what is this. Okay, great. Yeah, everything is great. We need to make the X become the radius times 2. Radius scale times radius times 2. Yep, we got that. Everything is great. The last thing, maybe we should create another text for the area. It should be area. And don't forget to make it to fix by 2, and then we make sure this become Y. Yep. Everything is correct, I think. Yep, that's great. We have already tried to implement the basic circle animation in Motion Canvas. And we also learn about the dynamic versus static value that we can apply to the props. Like if I make no function here, I make no function here, and I make no function here. If we refresh and try to, yeah, you see that it's not dynamic. The value for this one not dynamic, and the circle itself not dynamic. It's just calling the value, not computate that value continuously. So that's great. Yep. Let me add to my Git changes. So what's next? What kind of product are you building? I'm building pixeldeveloper.io, and for this video I'd like to, maybe you can't see my command, and for this video I'd like to learn about a motion canvas to create a slides presentation for my next YouTube video. I'm building pixel, and for this video I'd like to learn about motion canvas to create for my next YouTube video. Yeah, I think it's great. Okay, let's continue to learn about motion canvas. Okay, this is great. Next is Evex. Evex let you observe changes to signal and react to them. Observe changes to signals and react to them. Unlike signals, effects are not lazy. Create the effect, run the callback immediately after any of its dependencies changes. Create deferred effect, runs the callback at the end of each frame during which any of its dependencies changed. They are useful for side effects such as modifying the node hierarchy or spawning background animation in response to a change in some signals. When it comes to modifying the properties of nodes, prefer to use signal. Wait, I don't get it. Effects let you observe changes to signal and react to them. Unlike signals, the effects are not lazy. Okay. A create effect runs the callback immediately after any of its dependencies changes. Create effect runs the callback immediately after any of its dependencies changes. Create defer effects runs the callback at the end of each frame during which any of its dependencies change. When it's come to modifying the property of nodes, prefer to use signal overview. Effects are created using the create effect. Signal change. Okay, it observes changes to signals. Okay. The first argument specifies the callback to invoke. The first argument the first argument specifies the callback to invoke. After creation effects can be disposed of using the return function. Dispose. What is dispose? Unsubscribe. To understand the difference between signal and effect, consider this modified example from the signal section. A cons radius create signal 1 area create signal console log. Wait, the create signal. The create evec public create evec callback void. It's only have one argument, which the callback to invoke. Okay, but how this evec know the changes that they will observe? Create effect signal Okay, after creation, effect can be disposed of using difference between signal and effect. Consider this modified example from the signal section. Create signal mat.py. I still don't get what is the evec actually. The area signal is invoked inside an effect. Instead of being called directly, now whenever the radius signal changes, the effect is triggered, which recalculates the area signal instantly. Compromise. On one hand, you can now react to changes immediately without having to invoke the signal each frame. On the other hand, all dependencies on the effect are no longer lazy. This shouldn't be a problem, but if the dependencies of the effect change often and are expensive to calculate, this may affect seeking performance. Divert effects. I still don't get what is the effect does. In your effect references multiple dependencies that change often, you can use create divert effect to defer them. Okay, to stop them until the end of the current frame. This way the effect is only executed once even if multiple dependencies changes. The downside is that the side effect caused by the default effect are not immediately visible. They will become visible after the current generator step is finished, but before the rendering starts. I still don't get what is effects mean. How to use effect to automatically update the node hierarchy so the amount of circle display matches the value of the count signal. We create signal, we create the container, align item center, okay, ref container, and it will become layout. We have the circles, a bunch of circle as an array. Create effect, target count, mat.round of count, circles dot length. We call it count first 1, then 6, then 4, then we yield to 0. Create effect. Why we should use effect? Anyone knows why we should use effect in motion canvas? Layout, align item center, ref container layout, and we add the circle. We spawn the circle. Remove any extra circles, add any missing circles. For target count, I++. We add or remove extra circle. Mat.round the count itself. Why we must round? Because signal give us not the rounded value. Signals. Yeah, signal. I think it's not give us the rounded value. Let me check in here. Signal. Signal. Where is the signal? Oh, this one. Create a signal decorator, not this one. Do back weight. Here is this create signal. If we pass 0, it will get the t value. Initial. Wait a second. Simple signal t value. Equal with signal. But why? If I, for example, if we put 0 in create signal, it will call this function, right? We call it like create signal 0. But why we need to use it later? Maybe the signal signal dot to fixed, or maybe math dot round signal. Why we should round this, even though what we pass inside is a number, is an integer, not the float. This is the integer, not float. T value initial signal value, T value signal value, T value, T value, T value. I still don't got it. Maybe let me ask the LLM. Check the create signal file, and if we call create signal 0, why it's outputting the float number instead the int? How much time that I've live now? Deep up. Oh, this one using deep RP. Found it. The issue is in how deep lerp handles number interpolation. Here is what's happening. When you call create signal 0, it uses deep lerp as the default interpolation function. Looking at the implementation, what is deep lerp? Type of from map from to value. Core SRC twinning interpolation functions. The map function performs linear interpolation, produce floating point numbers. For example, interpolating from 0 to 10 at value 0.5 gives 5.0. Interpolating from 0 to 10 at value. Solution: if you need integer value, you have a few options. Rounds. Cons my signal. Oh, this is an issue? I don't know. But it's great. It's great to have create signal and we pass the number or integer type into our create signal, and it will give us the float number instead. I think that's how the animation works. Yeah, because we need to have the number between the value that we give. If we just use integer type, it will not create that bunch number. I don't know. The deep lerp, the interpolate between any two values, right? Including object array and maps. Okay, that's great. So whenever we create signal and we pass 0, it will create the float number instead. So that's why we should call it using math.round of our count, because the count itself, this one, it will become the float. So that's why we call the math.round. Okay, that makes sense. target count, we pass 1. So if we pass 1, circle dot length for target count, e plus plus circle is circle with white, as circle dot push. Oh, circles, we call it circles dot push circle container dot add. We have the container, this is the container. We add the circle, we spawn the circle. What is 80? Oh, this one, circle size 80. Okay, so I think I need to create it from scratch to know the create effect. But why we should use the create effect? Why we should use the create effect function? This is my next question. What's the create effect? I still don't got the purpose of create effect. I think it is the same thing with the signal previously. Let's tell it to my cloud. Why we should use effect in motion canvas? What is the distinction between effect and what is that called? And signal. I still don't get it why we should use create effect. So if we break down the animation, we have layout, we have circles, container, we have the circle, we have the condition as well. If we add more circles than this current state of circle, we should add it like this. If not, we should remove any extra circle. Circle dot size 0, do circle dot remove. Oh, we should remove it as well. The circle, we spawn again, but we remove them later. Good question. Here the distinction comes down to laziness versus eagerness in evaluation. Okay, signal are lazy. A computed signal only calculates when you explicitly call it. If nobody reads the signal, the computation never happens. This is efficient for derived values like effects are eager, they run immediately whenever any dependency changes, regardless of whether anyone asks for the result. You don't call an effect, it reacts on its own. The practical distinction: signal are for computing values. Effects are for triggering side effects. In this context, means anything that changes the world outside the reactive system, modifying the node hierarchy, spawning, animation, logging, etc. Consider a complex example in order to comment. The create effect watch the count signal and automatically adds or removes circle nodes when count changes. You couldn't do this with signal alone because signals just return values. Okay, signals just return values. They don't do things. The effect bridges the reactive world with the imperative world. One important trade-off: because effects are eager, they sacrifice laziness. If an effect depends on expensive computation that change frequently, it could hurt seeking performance. That's why the docs recommend using signals for node properties, which motion canvas already handles reactively. So it says about the reactive world with the imperative world. Okay, the create effect for example, if multiple events are updated in one frame, it only runs once at frame and rather than after each change. Okay, I think Everything makes sense now. The effect itself will observe the value that we call outside this function. Observe changes to signals and react. Oh, this one, and react to them. I think it's great to use my Excalidraw. Effect let you observe change to signal and react to them. So basically what effect did, oh come on, is effects is do something. If the signal changes, do something. That's why in Motion Canvas we have the effects. Yeah, let's grab this term first. So I think I need to create it from scratch. We have how much? Yep, I think I need to copy this. This is the animation. Come back to my cursor code editor. And we need to start from scratch. Oh, sorry. We should have this. Yep, should have the count. Wait for, and let's me create the comment first. So what we need is have the layout, and this will be flex. And also after we have layout, I think whenever we create the layout to our props later, it will automatically become flex, maybe the item center. And then after we have the layout, we need to have container of circles, and we have the circle as well. Let's we see the width 80, okay, 80 pixel, and we need to have the for loop to add or remove circle based on the circle dot length, because this will add, this will add, this will remove, and count 0 to it is the timing function, I think, timing number, so it will be 2 seconds. This will remove as well. From 4 to 0 is removing. If you don't know, this one is a signal, and this one is the timing, 2 seconds, right? Okay, let's start. We should have count equal with use, not use signal, create signal of 0. Great, nothing error. So we need to make the layout first. What we should do is to view.add, and then we have the layout. We should create the layout here and align items center. That's great. Oh, why we need to have the container? Oh, we should, yeah. Const container equal with create ref of the layout, and we can put the ref of container, container ref container ref, and we should use the create effect. I think something like this to using create effect. Okay. So for the create effect, we are calling the callback function. Inside the callback function, what we need to do is, let me check the code base. Yep. Const target count equal with the count itself, because we change it over time, the count, and don't forget, if we call the count, we get the value of our count signal, but it will become the float, so we need to round it using math.round, so it will become the integer, right? It's great. We get this one, and then we should have for what is I? We should define the I itself. I is the count, circles.length. Wait a second, why I is circle.length? I think it should be const circle length equal with, oh, I should make this one first. Const circles or let, yep. Const circles is this one, circle is circle like that, circles dot length. If circles length, if circles length target count, we need to add the loop, add more circle, remove circle, and circles length. Why we should wait a second. I plus plus, we should use let. Yep, because if we using the const, it's immutable. We cannot change the value inside the circle's length, so we need to make it let. Okay, great. So how do we make, we need to push, right? Maybe we can use const circle equal with view dot add circle itself, and the size maybe the 80 like that, and fill is white, and we should push circles dot push the circle. Why it's happen? It's not assignable to type to parameter of type circle. Circle. Oh, not view dot add. We just use circle as circle. We should have the size 80, and then the fill of white, and we push the circle. After that, oh, we post, but we need to add to container. Yeah, container ref dot add. Sorry. Add the circles. Why we should spawn? But let's see that. What happened? There's nothing happen. There's nothing happen in my code. Okay, so we should spawn the circle dot size. Oh, we don't use size here. 80. Should we have maybe, yeah, we got that. Oh, cool. Whoa, that's cool. But why we need to spawn? Because I think whenever we add the circles into container ref, it's already add. Oh, nothing happened. Nothing happened. Why we should call the spawn function inside ball.sx? I think whenever, in my opinion, whenever we add something into container ref, it's already being added there. I still don't get why we should spawn. Oh, I've already did the live stream almost 1 hour now. Okay, great observation. Let me explain the difference between add and spawn in Motion Canvas. Adds the circle to the scene graph. DOM, okay, I know the scene graph. Makes the circle exist in the scene, but this alone doesn't animate it. Oh, I think if I just did something like size 80, we get that, right? Yeah, we get that. If we do the size here, we are getting the circle, but we don't have the animation yet. So that's why we use the spawn, right? A spawn circle runs an animation that twins the circle size. Ah, I got it. I got it, friend. Yeah, I got it. So that's why we don't use the size inside it, because we want to animate. If we oh, that's something interesting. What happen if I make size like size, but using function like this? Oh, I think we couldn't do that. We couldn't twins the state of the size of our circle into this circle component. So we need to spawn it. Okay, cool. And remove the circle. We need to create 4 circle length, target count, circles length minus, and we should have, oh, we don't need that. I think we just circles dot pop the circle the maybe like that. I don't know. Yeah, it's nothing. Cons circle dot pop. Cons circle And then we spawn again. I think spawn the circle dot size become 0 for 300 millisecond. Yep, let's try to look at this. Yeah, but we need to remove that as well. I don't know why we should remove. Do the circle dot remove. Yeah. Yep, that's great. Yeah, that's great. But I have a question also. Without spawn, call the circle will just pop into existence at whatever their default size, with no smooth animation. Yeah, that makes sense. Alternative approach: if you wanted the circle to appear immediately at size 80 without animation, you could do, yeah. But the current code uses spawn to create a smooth growing animation when circle appear, which is more usually appealing. I want why we should call the callback function of call.remove after we did spawn circle to 0 size when we remove it. Why we should do this one? It is because we need to remove the scene graph, maybe. I don't know. Oh, I think yeah. I got the answer, I think, because we can use the scene graph here. So at the first, scene graph is nothing, and we run. Maybe we have layout. Yeah, great. Circle. Why it's too much circle? Yeah, I think we just need to remove that. So if I don't do this, right, and try to run the animation again, we have circle, we add more circle, and yeah, it's not removed from the scene graph. Yeah, I think this makes sense. I think this makes sense why we should remove it, to remove from the scene graph. If you don't know about the scene graph, you can read about it inside the motion canvas documentation. Where is the scene graph? Scene graph, I think somewhere. Scene hierarchy, this one. This is the scene graph. It's like DOM, right? So we need to remove it as well to make sure our animation is lightweight. Okay, great question. This gets at an important distinction between visual appearance and scene graph management, right? As I said previously, when you do spawn circle, but it's still in the scene graph, the circle object is still there, just invisible. This means memory leak, performance, and logic issues. You need circle remove to actually remove it from the scene graph. Oh, cool. Here's the proper pattern for removing circle. If circle spawn, circle remove. Think of it like actually delete. Yep. Okay, that's great. I need to make the commit changes for what I've learned about the effect. Where is my... yeah, I think I need to make it here. Lazy git, and then fit learn about effects. Yeah, that's it for today. Thank you for watching, and see you in the next line.